I'm going to be honest with you. When I first started working on mixture problems, I really did not like them. However, I've learned some strategies since teaching here at CBTC actually that have made these a lot friendlier. So I'm going to show you a couple of ways to work some of these, and you can decide which works best for you. One way involves simply figuring out the the two equations in your system to solve for. The other involves using a box, like the one seen here. So why don't we take a look at the first example? I'll show you how to do it using just the equations, and then I'll show you how to do it using the box. A science teacher sold 1,363 tickets on a busy weekend. The receipts totaled 12,146. How many $12 tickets and how many $7 child tickets were sold? So $12 adult tickets, $7 child tickets. Let's take a look. So let's call the adult tickets X and the child tickets Y. We know that a total of 1,363 were sold, of some combination of the two. So all the total number of adult tickets plus all the total of child tickets equals 1,363. The total receipts were 12,146. So, what were the cost of the adult tickets that would give us this value? $12 per adult ticket. Plus, what was the value of the child ticket? $7 per child ticket gives us 12,146. So we have to figure out how we can solve this system. I think the best answer is with substitution. I'd hate to multiply this number by a -7 and try to figure that out. So let's substitute. Let's solve for y. Y equals 1,363 minus x. So we'll substitute that in for this y. Get 12x plus 7 times 1,363 minus x equals 12,146. 12x plus, don't want to multiply that in my head, 1,363 times 7 equals 9,541. Minus 7x equals 12,146. Combine like terms, we get 5x plus 9,541 equals 12,146. Subtract 9541 from both sides, and we get 5x equals 2605. Divide both sides by 5, and we get x equals 521. Now we know a total of 1,363 were sold, so we can plug x back into this equation and solve for y. So we get 521 plus y equals 1,363. Subtract 521 from both sides. And we get 842. We can check our answers. I'm going to plug these both into this equation just to make sure it adds up. So 12 times 521 plus 7 times 842. Make sure that equals 12,146. So 6252 plus 7 times 842, 5894 plus 6252 gives us 12,146, so these should be correct. So 521 adult and 842 child. Another strategy using the box. Lots of boxes in this class. There's the box method, there's this box. So what we're going to do is we're going to have a row for the headers, a row for one item being adult, a row for the other item being child, and the last row is total. So this is the ticket type. First is adult, then child, next is the number of tickets. Number of tickets for adult we set as X. Number of tickets for child we set as Y, but then we use substitution. So Y is equal to 1363 minus X. And our total is 1363. So if we look at this column, if we add these two together, we should get what's in the total. And we do. Then we have how much each is worth. So the adult tickets are $12. Child tickets are $7. How much is worth total doesn't make any sense. We'll just forget about that one. And then profit. Here we multiply these two columns together and set it equal to the last column. 12x is a profit for adults. 7 times 1363 minus x is the profit for children. And the total profit we're told in the problem is 12,146. Now, with this final column that we just calculated, we are going to take the first two, add them together. So these two are going to add together to equal this last bottom right-hand cell. So let's go ahead and do that. 12x plus 7 times 1363 minus x equals 12,146. And that should look familiar right here. This is the exact same thing that we wrote right here. So these are two different strategies that you can use. I'm going to continue using this box method because I feel like the first strategy is something that's pretty intuitive, whereas this one might take a little bit more practice to get used to. I really like this box strategy myself. It makes a lot of sense to me, but we'll see how we do in the next few problems. All right, Juan has a pocket full of nickels and dimes. The total value of the coins is $8.10. So, let's start with our box. I don't think this box is going to be big enough, so I'm going to make it a little bigger. So our first column is just our labels. Then we're going to have usually about that many. So this is the coin, nickel, dime, total. So this is the value of the coin. giving us a total value of all the coins put together at $8.10. So I'm going to put these in terms of dollars instead of saying that they're worth 5 cents and 10 cents. So this is worth $0.05. This is $0.1. Total doesn't make any sense for this, so we'll just not worry about it. So now we have the number of each coin. Now, this one's kind of gross. The number of dimes is 9 less than twice the number of nickels. So let's say nickels is X, dimes is Y. So the number of dimes, Y, is equal to 9 less than twice the number of nickels. So 2 times the number of nickels minus 9. So this is our dimes. Nickels is simply X, dimes is 2X minus 9. Total number of coins is going to be 3X minus 9, because we just add these two together. Then the total value of what he has in his pocket, we are told it is $8.10. Nickels, we're going to multiply over to get the value of the number of nickels that are in his pocket. 0.05 times X, which is the number of nickels, and then we have 0.1 times 2X minus 9. Now we're going to take these two, add them together to equal what's in this cell. So we'll take 0.05x plus 0.1 times 2x minus 9 equals $8.10. We'll distribute, and we get 0.05x plus 0.2x minus 0.9 equals 8.10. Combine like terms, 0.25x minus 0.9 equals 8.1. Add 0.9 to both sides, 0.25x equals 9. Then we'll divide both sides by 0.25, which is the same thing as multiplying by 4, so we get x equals 36. So what is y then? Let's plug 36 back into this equation and find y. Y equals 2 times 36 minus 9. Y equals 72 minus 9. Y equals 63. So x is 36 nickels. Y is 63 dimes. Let's double check to make sure this makes sense. So the number of nickels is worth $0.05 plus 0.1 times 63 equals $8.10. Oh, that one I'm not going to do in my head. 36 times 0.05 is 1.8 plus 6.3 is $8.10. It does work out, so these are the correct answers. All right, problem number 3. Carson wants to make 20 pounds of mixed nuts using nuts and chocolate chips. Trail mix using nuts and chocolate chips. His budget requires that the trail mix cost him $7.60 per pound. Nuts cost $9 per pound. Chocolate chips cost $2 per pound. How many pounds of nuts and how many pounds of chocolate chips should he use? So we know that the pounds of nuts and the pounds of chocolate chips has to equal 20. So we'll say X equals nuts y equals chocolate, x plus y equals 20. So if we solved in terms of x, we get y equals 20 minus x. So that's going to be our chocolate. Nice big box this time. All right. So we have ingredients. We have nuts, chocolate, and total. Let's see here. We have pounds. Total pounds is 20. The nuts are x. Chocolate is 20 minus x. We have cost is $9 a pound. Chocolate is $2 a pound. Total cost doesn't make much sense, so we'll just scribble that out. So the cost is 9x for each pound. 2 times 20 minus x. Now the total cost he wants is $7.60 per pound, but he wants to make 20 pounds. So $7.60 times 20 pounds equals $152 as a total cost. And we could have put the cost here, the total cost that he wanted per pound. We could have said $7.60 because we were multiplying across, and we did multiply 20 times 7.6. So we're going to add going down. So we'll have 9x plus 2 times 20 minus x equals 152. We'll distribute. Combine like terms. Get all the constants on one side. And let's see what we get. 16. So what's y? Well, we have it up here, so let's solve for that. Y equals 20 minus 16. Which is 4. So we need 16 pounds nuts and 4 pounds chocolate. All right, one more example before you try a few of these on your own. It's completely up to you if you want to use this box method or the first method I introduced in this section. Shashina is a lab assistant at her community college. She needs to make 200 milliliters of a 40% solution of sulfuric acid for a lab experiment. The lab only has 25% and 50% solutions in the storeroom. How much should she mix of the 25 and 50% solutions to make 40% solution? Let's get our box ready. So solutions, what we're going to have here is what she has. She has a 25%. She has a 50%. And our total row is going to be what she needs, which is 40%. So her total, when she mixes these together, is going to be a 40% solution. Make sure you're not putting these in numerical order. We want the final result in the bottom every time. We did this in the trail mix problem above too. All right, so she needs 200 milliliters. So let's say, what is the percent as a decimal? 0.25. 0.5. This is just going to help us multiply a bit better so we don't forget to turn it into a decimal later. This is going to be the amount. We don't know how much. We know she needs 200 milliliters total. Let's call one of these X. I'm just going to call the first one X because it's the first one. Now, when we add these two together, we're going to get 200. So this is going to be 200 minus the 25% solution we're putting in. Now, this is the amount acid. And just like before, we're multiplying across to fill in our final column. So we get 0.25x, 0.5 times 200 minus x, and 0.4 times 200. Then we're going to add these two together to equal what's in this last box. So our equation is going to be 0.25x plus 0.5 times 200 minus x equals 0.4 times 200. So let's distribute 0.25x plus 100 minus 0.5 equals, 0.5x equals 0.4 times 280. Combine like terms, we get negative 0.25x plus 100 equals 80. Subtract 100 from both sides, we get negative 0.25x equals negative 20. Divide both sides by 0.25. Same thing as multiplying by 4, and we get x equals 80. So x, our 25% solution, is going to be 80 milliliters. How about our 50% solution? How much are we putting that in? Well, we'll look in this box, and it is 200 minus x. 200 minus 80 is 120 milliliters. So that is our final answer. Be sure to reach out to your instructor if you have any issues with these. We can definitely work with you to make these easier for you. If the box method is not working for you, we can work more with the original method that I shared at the beginning of this video. Good luck!